In this problem, it has a question and then has the solutions already there for you. So when it talks about polygon A, that's this triangle here. The best thing you can do is recognize that it is 2 units across and then 3 units long or down the side. So that's the side lengths of the original triangle. Now when it says the solution is 1.5, that means that B is a scaled copy that's used 1.5 as a factor. So if we look at the sides 2 and 3, the question is, or you can explain that this length is 3, and going down the side is 1, 2, 3, 4.5 spaces. So I can set this up as a proportion and see that these are equivalent because 2 is to 3 as 3 is to 4.5. You can see this many ways. I know that 2 times 1.5 is 3, and that's where the scale factor comes from. The same thing with 3. 3 times 1.5 is 4.5. And so for C, it's not a scaled copy because the width here is 1, 2, 3 is 4 spaces. And then going down, it's 1, 2, 3, 4. It's 5 spaces. So now again, we have the original shape A is a ratio of 2 to 3, and C is a ratio of 4 to 5. Well, there is no one factor that goes from 2 to 4 and 3 to 5 because 2 times 2 is 4, but 3 times 2 is not 5. So that's why C is not a scaled copy. And then for D, the scale factor is 1/3, and that's why it shrank because 1/3 is less than 1. So again, going from 2 to 3 for the original triangle, now this width, if it is 1/3 of 2, it's got to be 2/3. And then going down, it's 1 square, so it's 1. So now again, the question is this true? If we use a scale factor of 1/3, is 2 times 1/3 equal to 2/3? And it's yes. And then is 3 times 1/3 equal to 1? It's yes. That proves that this also is a correct scale factor. It shrank by a scale factor of 1/3. So when it says be as detailed as possible, you can explain how these scale factors make sense because of multiplication, and C is not a scale copy because there is no factor that multiplies both parts 2 and 3 to get 4 and 5. I hope this helps.